GATE 2019 Civil Engineering Set 1 Question 26. Question 26. Which one of the following is not a correct statement? Statement A. The function x root of x is greater than 0 has the global maxima at x equal to e. Statement B. The function x root of x is greater than 0 has the global minima at x equal to e. The function x cube has neither global minima nor global maxima. Statement D. The function mod x has the global minima at x equal to 0. Reference to the relevant NPTEL courses or video has been cited. Now coming to the useful data, we know that there are certain conditions which are required to be fulfilled for maxima and minima. So let's say for maxima we have a function fx here. Let's say the function fx is maximum at a point x equal to x0. So we can clearly see that at x equal to 0, the slope, if you draw the slope at this point, we are getting the slope here 0. So the tangent at maxima will be 0. So the first condition which becomes is df of dx, that means the slope at x equal to x0 will be 0. So we can clearly say that for a function to be maximum, the slope at x equal to x0 means the point where it's getting its maximum value should be 0. And we can clearly see here that before the maxima, if we draw the tangent, we are getting a positive slope, and after the maxima we are getting a negative slope. So we can clearly see here that the change of slope is from positive to negative. So the second point could be the second derivative of function d square by f of dx square at x equal to x0 should be less than 0 for a function to be a maxima. Now coming to the minima, if let's say this is a function fx, and it's getting its minimum value at, let's say, x equal to x0. So like that of maxima, the slope at x equal to x0 will be 0, 0 at x equal to x0. So the first condition becomes df of dx at x equal to x0 will be 0 for a for minima. And the second condition will be, we can clearly see here that before the minima, if we draw the tangent at some point, there is a negative slope or negative tangent we are getting, and after the minima, if you see, we are getting a positive slope here. So the change of slope is from negative to positive, and in maxima it was positive negative, and here it is negative to positive. So we can clearly say here that the second derivative of d square by f of dx square at x equal to x0 will be greater than 0. So these are the conditions which are required to be fulfilled for maxima and minima. Now coming to the video solution, the first statement says the function x root of x is greater than 0 has the global maxima at x equal to e. So let's say the function y here is x root of x, which can be written at x power 1 by x. So if you simplify it by taking log on both sides, it will become log y equals log x by x. Now we can write it like that also, y equal to e की power log x by x. Now we know that for maxima and minima, the function df by dx should be 0, means the slope should be 0. But now but here the function fx, we are considering log x by x for our simplification. So this is our function log x by x. As we know that df by dx can be written as f dash x equal to 0. So now if we differentiate it, we will get x into 1 by x minus log x divided by x square equal to 0. We can write it like that, 1 minus log x divided by x square equal to 0. 1 minus log x equal to 0, which will become log x equal to 1. So if you simplify it, we will get x equal to e. So we can say that at x equal to e, our function is either maximum or either minimum, but that we don't know. And at x equal to e, our function will be 0. At x equal to e, df by dx will be 0. That means the slope at this point will be 0. This is our x0. Now if we get the double derivative of the function, that will become x squared into minus 1 by x minus 2x into 1 minus log x divided by x to the power 4. Now if we simplify it, we will get minus 3x plus 2x into log x divided by x power 4. Here we have used the UIV rule that we know. So for simplification, I have just written the whole derivation here. So now if we put the value of e in place of x, we will get minus e divided by e power 4, which is minus 1 by e power 3, which we know that the value of e is positive, so this value will always be less than 0. So it says that the double derivative is less than 0, hence at x equal to e it is getting its maximum value. That says that the function x root of x has the global maxima at x equal to e. So the first statement becomes correct, and the second statement says the function x root of x is greater than 0 has the global minima at x equal to e, which is wrong, because as we have just seen here that it's getting its maximum value at x equal to e. Now coming to the third statement, the function x cube has neither global minima nor global maxima. Now if you draw a graph of x cube, we get a graph like this. See here that it doesn't have any global maxima or minima because it is going in the infinite direction, and we can't say that where it will get its maximum value or where it will get its minimum value. So it is quite uncertain that that the function x cube has a either global minima or global maxima. So the statement C is correct, because we can't clearly say that where it will get its maximum value and where it will get its minimum value. And the fourth statement says that the function mod x has the global minima at x equal to 0. So now if we draw the graph of mod x, we get a graph like this, and we can clearly see that at certain points it is going in the infinite direction, but at x equal to 0 it is getting its minimum value, which is 0. Because if you put the value of x equal to minus 1, we will always get the value in positive. So we can clearly say that the function will always be positive, and we will get its minimum value at x equal to 0. So the fourth statement is also correct. So as we have clearly studied all the statements very well, so we can clearly say that option A, option C and option D are correct, but we need to find here the incorrect statement here. So the option B is the incorrect statement, hence option B will be the answer for this question. Reference to the relevant NPTEL courses or video has been cited.